All right. Okay. Good evening. Welcome to episode 14, season 2, Axiom Flux. And I'm STAV, and tonight we're talking about energy. And also on with me tonight we've got Paul. Good evening, Paul.
Good evening, folks.
Right, and also Bok. Evening, Bok.
Evening, Andy. Evening, Paul.
Right.
Good evening.
Okay. Well, what we've got then is it's all about energy. And what is energy? That's the question. We should all know what it is. We wouldn't get by without it, would we? We wouldn't exist.
Vibrations.
Yes, that's right. So, but the type of energy we're talking about tonight is mostly electricity. You know, one or two bits and pieces hopefully will clear up to people that may not know. Bear with me if it's a little bit beginnish because I'm not an expert, but I do have a basic sort of understanding of electricity and electronics from my youthful days. So it's a bit of a revision course for me tonight as I go along. So anyway, I'm gonna pop this on here, present to everyone, and we're going to bring up some articles and hopefully give you a little bit of an understanding about what is what here. And here we go. Hopefully, I'll just check with the boys because I'm having to do this as I go along as well. Can you see the screen, Paul?
Yeah, loud and clear, mate.
Okay, well, here we go. This is e-school today, right? So I'm taking you back to school. Which I don't know if they do this sort of thing in schools today, but it'd be interesting to hear from anybody who comments, any people that know whether school teachers and that do actually do this in schools today. It'd be interesting to know that, just normal schools anyway, or just the general, you know, state schools or whatever it is. It would be interesting to see. Anyway, what is energy? Look around you. Is anything moving? Can you hear, see, or feel anything? Sure, this is because something is making something happen. And most probably there is some power at work. This power or ability to make things happen is what we can call energy. It makes things happen. It makes change possible. Look at the sketch below to see an example of things working, moving, or happening with energy. They've got some planes and balloons moving, cars, cyclists. Anyway, there it is. Energy moves cars along the roads and make airplanes fly. It plays our music on the radio, heats our rooms and lights our homes. Energy is needed for our bodies, together with plants to grow and move about. Scientists define energy as the ability to work. Energy can be neither created or nor destroyed. And we've got different types of energy here, which the ones we'll be just touching on tonight is just basically electrical energy. It's a good little site, this. I must say so myself. I said I was revising, didn't I? Anyway, kinds of energy. Well, electrical energy, just electrical energy. Matter is made up of atoms. In these atoms, there are some even small stuff called electrons. That's these things here. That are constantly moving. The movement of these electrons depends on how much energy it has. This means every object has potential energy, even though some have more than others. Excuse me. Humans can force these moving electrons along a path from one place to the other. There are special materials called conductors, that carry this energy. Some materials cannot carry energy in this form, and they are called insulators. We generate electrical energy when we succeed to cause these electrons to move from one atom to the other with the use of magnetic forces. See, you've got these here. You want to induce them into there, right? You can do that via changes of either in between, and we won't go too much in it. That's the electron. He can jump over to that one, and then he can jump over to that one, or he can jump there. These electrons can move into there, and then other electrons can move into there, or gather free electrons that might be spinning around, and they go, oh, a nucleus, so I'm being positive and I'll pull it. Anyway, we won't go on anymore, but that's the movement of electrons, right, across from one atom to another. Once we harness electrical energy, it can be used for work or stored. How does an electric current work? A battery transfers stored chemical energies as charged particles called electrons, typically moving through a wire. For example, electrical energy is transferred to the surroundings by the lamp as light energy and thermal heat energy. Lightning is one good example of electrical energy in nature, so powerful that it is not confined to a wire. The thunderclouds build up large amounts of electrical energy. This is called static electricity. They are released during lightning when the clouds strike against each other. Well, that would be sheet lightning, and we normally call that from cloud to cloud. So basically, energy is what is produced by these electrons moving from one atom to another, and we can induce that movement by doing certain things, by connecting up conductors, and if we don't want it to go a certain way, we can use insulators to stop that flow of electrons from atom to atom, if you like. So the next one I'm going to go to very quickly is radiant energy, which is what really most of tonight's really about. For me it is anyway, and hopefully for anybody listening. Well, radiant energy is an energy of electromagnetic waves. It is a form of energy that can travel through space. For example, we receive the heat from the sun, which is located very far from the Earth, via radiation. The sun's heat is not transmitted through any solid medium, but through a vacuum. This is possible by electromagnetic waves. Before we go any further, let us understand what electromagnetic waves are. Each time static energy from electric and magnetic forces come together, they induce an electrical field around them. An example of electric static force is the shock you get when you hold a metal doorknob. An example of magnetic force is the pull that extracts metals to the magnet. Now, the electrical field induced causes waves called electromagnetic waves, and they can travel through vacuum, air, particles, or solids. These waves resemble the ripple mechanical waves you see when you drop a rock into a swimming pool, but with electromagnetic waves, you do not see them, but you often can see the effect of it. The energy in electromagnetic waves is what we call radiant energy. There are different kinds of electromagnetic waves, and all of them have different wavelengths, properties, frequencies, and power, and all interact with matter differently. The entire wave system from lowest frequency to highest frequency is known as the electromagnetic spectrum. The shorter the wavelength, the higher the frequency. That's that end, yeah? You see the wavelength is nice and long, the troughs, and then it gets shorter and shorter and shorter. The peaks get closer and closer. So the actual wavelength becomes shorter because wavelength is across the wave, not up and down. That's amplitude. These are sin waves. And have a 0 point right through the middle of there. You'll have positive, then negative, either side of the 0 point. The 0 point is the Holy Grail, if you want to call it that, of energy.
Would that be analog?
Yes, that's right. That would be a sin wave, Paul. Each one of these, okay, from peak of, well, let's just say 0, say the 0 is right through the middle there. 0, you've got a plus peak, back to 0, and you've got a minus peak, back to 0. So from that point there to that point there is one wavelength, one wave, one sin wave, okay?
Is it always equal to plus and minus of the wave? Is it always equal?
It's both equal, both sides of it, yeah.
Yeah.
It's 180
Yeah, so
degrees.
no matter how much you increase it or decrease it, it's still equal both sides of the 0 line.
That's right. It's 180 degrees phase, peak to peak. So together, the whole wave, you've got 360. So from the peak there would be, if it, the maximum, and there's the maximum positive is if we have a line through here and we count going up as positive voltage, positive, and then we come down to 0 again, then we go to negative peak, back to 0 again, because negative peak is not 0 point. 0 point is through the middle. So if this was like, if this was like peaks of a voltage, say 12 volt peak, right? In DC, I'm sorry, not DC. If it was a 12 volt peak RMS AC sin wave, which is a little bit over people's heads, but anyway, let's just say it'd be 12 volts there, plus 12 volts there, plus peak 12 peak, plus 12 volts peak there, plus 12 volts peak, and minus 12 volts peak there. Okay?
Right.
So plus and minus of 12 equal, and 0 right slam through the middle, which is the 0 point right away through the middle. Yeah? Are you with me?
Yeah.
Okay. When radiant energy comes into contact with matter, it changes the properties of that matter. For example, when microwaves, which forms part of the entire spectrum, are set off in a microwave oven, the water molecules in the food are charged and caused to vibrate billions of times per second, generating heat. That causes the food to cook. The microwave oven works with the concept of radiant energy, electromagnetic waves. So a lot of people don't understand that when they use a microwave oven, that there's not two electrodes in there which you plug one in the bird's bum and one in the bird's head if you put it in a microwave, and it don't work like conventional. It's done through electromagnetic waves pulsed at microwave levels, which is quite high. There it is there, microwaves. See them? You've got radio waves, and then the next highest are class microwaves. What I would like to add in this, just for whatever, you can cook things in here using microwaves. Yeah, you can cook flesh, whatever, meat, whatever, and boil water, do what you like. But it also happens to be the microwave oven frequencies use those frequencies, but also mobile phones use them frequencies, and also routers, Wi-Fi use them frequencies. Now you can understand why some people are a little bit alarmed by that. But anyway, that's just a bit of an additional, but the powers are so low that they say it's detrimental, but it's not detrimental to your health. But if powers were brought up to microwave oven levels, then you might be seeing a lot of problems in the not too distant future. Well, that's just the basics on radiant energy, which is electromagnetic waves, and that's as far as I really want to take this little tutorial. We could go on to kinetic energy and mechanical energy, but for the moment, because it will lead me into my next article, and this is this guy here called Nikola Tesla. If anybody knows anything about Nikola Tesla, they will know all of what his patents were all about, why the world wouldn't be like it is today if it wasn't for Nikola Tesla, with his induction motors, AC transformation, and generation of AC. Let's be honest. Every morning you get up, you switch a light on, or you switch a switch down in your house, and you have electricity. Now, if it wasn't for Nikola Tesla, unless somebody else thought of it, you wouldn't have that today. So the world would be very, very different without this chap.
What a guy!
Yeah, absolutely. And he invented and designed all types of things, from neon bulbs like the one fluorescent neon bulbs. That was a long time before they come on the market. Well, he was messing around with radiant particles inside a vacuum, and making it all light up with radiant energy, and lots of things. X-rays. He actually built the first X-ray machine. Radio. Although there's most Italians would argue with you that Marconi invented radio. Well, no, actually the patent belongs to Tesla. So I'm not going to go into the story and the argument over that's a separate thing altogether. But there you are. He invented radio.
And he was top again.
Yeah, absolutely dozens and dozens of other things that you can go and look up yourself if you don't. But it just says here, Nikola Tesla at the turn of the century patented a plethora of new inventions, mostly in the electromagnetic field, and it's thanks to his man that all today's technological amazements are possible. For it is he who brought us AC electricity, polyphase, multi-phase alternators, and the equipment to run on them. He is the true inventor of radio, not Marconi, and built the world's first remotely controlled vehicle. That's another thing I've mentioned. Remote controls and Wi-Fi is all because of this man, really. He is the true inventor of radio. Oh, sorry, and built the world's first remotely controlled vehicle. Proposed and was building a system for transmitting the required power to operate any equipment without wires at great distances from power source, as well as transmitting and receiving information, not just text either, but voice and message, much like the internet of today. And it was also with this system that he proposed a type of radar which was based upon the way a sinusoidal waveform would transverse through the Earth itself. There we go. Mr. Tesla also realized how to convert high current, low voltage to high voltage, low current, and vice versa with two strands of coiled wire, which are called primary and secondary transformer coils. Transformers work by magnetic induction, a growing and shrinking magnetic field. These transformers include step-up or step-down, center tap induction coils, step-up transformers provide the blah blah, ignites the fuel to run our cars, like the coil system. Yeah. Unlocking the key to resonant frequencies, which he seemed fascinated with, was crucial to the advancement of the human race. We could now build radio. The man was crucial to the development of electrical knowledge, and the list of his experiments and patents really does go on and on and on. But there is one patent that would be a system for utilization of natural electrical energy, which he called radiant energy. Mr. Tesla discovered that a metal plate raised at a height from the ground with a wire connected to it and running down to one terminal of a capacitor, the other terminal of which he would connect directly to ground. The capacitor would become charged, filled with electrical potential. He constructed a means of periodically discharging the capacitor through a device and thus harnessing the power of the cosmos. Mr. Tesla claimed the patents for this device and, don't quote me here, made headline news. Mr. Tesla's discovery, it seems, is not quite understood, but my estimates are cause and effect. The Van Allen belt, or belts, are belts of charged particles that surround the Earth's atmosphere. Check it out on Wikipedia. These belts could be causing the effect either by 1. Stimulating atoms, ionization, through the regions of the atmosphere. 2. E-fields generated by some 300,000+ volts at the ionosphere as a capacitive effect with the Earth. Stray charged particles from the Van Allen belts, otherwise it's not the Van Allens. The plasmatic effect created by a light beam striking a conductor with dielectric surrounds. Higgs boson decay into Z bosons, W bosons, or photons, all of which can create electrons. Radio signals, gamma rays, or X-rays set up by lightning strikes, even from miles away. Terrestrial magnetism, the fact that the Earth is like a giant magnet with north and south poles, may be inducing the charge from the Earth. Possibly even terrestrial causes like the Earth, I don't know, don't quote me. Other phenomenon planets, pulsars, quasars of space may have magnetic fields like the alpha waves of the sun, and these magnetic fields may be causing inductance or ionization. Interstellar nuclear activity, radiations from the sun, including the solar flares or other planetary phenomenon, black holes, pulsars, quasars. Whatever it is, it's definitely there, and Mr. Tesla's circuits work. We must take into consideration that the year was 1901 when it was discovered, minus the lightning. There was not much if any man-made radio waves in the air back then, which is a good point because it couldn't have been induced from mains, it couldn't have been induced from anything else because nobody was transmitting radio waves on the Earth in those days. So where was this energy coming from? So basically, it had to come from space, yeah. It had to come from off this planet somewhere. So there's tons of stuff about Tesla out there. I mean, we could talk for hours and hours, or make several talks on Axiom about it. I hope we do revisit it because I think we're in an era now where things are really starting to take off. Now, this chap here is called T. Henry Moray, and not a lot is known about him because Tesla takes a lot of it, and rightly so. But this chap here carried on Tesla's experiment with free radio energy collecting, and he built a different system slightly on the same theme to collect this radiant energy. He was quite successful at it at the time, but like all of these guys, including Tesla, if you become any threat to the mainstream cabal, whatever you want to call it, of oil dependency, generation of electricity by coal or whatever, in other words, you want it, you've got to pay for it. These guys get clamped down on, and this chap particularly was. But anyway,
is that not why Morgan clamped down on Tesla, because he couldn't meter and charge for it?
Absolutely, Paul. Yeah, that's right. That's written down, and that's fact written. You can find that anywhere, and that's right. Once they knew they couldn't charge, they couldn't put a charge on any of this because it was basically free, and anybody with a free energy collector or radiant energy collector could tap into as much power that they needed. I mean, you wouldn't need these conglomerates, cabals, and corporations, so they would need to go away. So they didn't want that, as we all know. And there we are. Yes, absolutely. Well, this guy was just pretty much, he came up against the same. Anyway, I read you the article. It's not too big. From time to time in the world, men of vision receive little or no recognition for their work, passing on to leave behind a legacy for others to follow. Such men as STAV, a Spanish physicist who demonstrated radio 150 years before Marconi, Joshua Coppersmith, who preceded Alexander Graham Bell, and this amazing clip from 1873 newspaper, Gustav Le Bon, who predicted the atom bomb in 1891, and Nikola Tesla, see the link on the page, the father of our modern system of electricity, found themselves isolated from the rest of the world because they would not accept the dictates of big business and outside pressure groups. Such was Thomas Henry Moray. Thomas Henry Moray, born August 1892 and died in May 1974, was an inventor from Salt Lake City, Utah. Moray graduated from the Latter-day Saints Business College. Moray studied electrical engineering for an international correspondence school course. He received an electrical engineering degree from the University of Uppsala at the turn of the century. Moray developed a reported inexhaustible environmental energy source by means of radiant energy. In the 1920s, Thomas Henry Moray demonstrated a radiant energy device to many people who were unable to find a hidden power source. Moray called his device a solid-state detector, or the Moray valve, consisting of a large antenna connected to a complex series of high-voltage capacitors, transformers, and semiconductors. By stimulating the existing oscillations of radio energy from space, the device ran for several days, producing 50 kilowatts of power. The demonstrations attracted newspapers and scientists from Bell Laboratories and from the Department of Agriculture, but none could attest to how the device actually operated, nor could evidence of fraud be found. The device was eventually destroyed by his assistant, whom apparently was angered that Moray would not sell his device to the corporate interests. Or there may have been more to this. See what I have written below. Moray was a follower of Nikola Tesla. As a youth, he greatly admired Tesla In particular, was very interested in Tesla's obsessions with the Earth having a limited supply of energy available to it from the universe. Like Tesla, Moray wanted to find out how to tap this energy. Like a lot of people, he became amazed at the crystal radio, where a crystal can be tapped with a fine wire to make a radio work without any battery or power. He figured that if this was possible, it should be possible to find a crystal or magnetic rock that could be tapped for a power source. He became very interested in the properties of certain rocks and crystal structures and the powders from them. This is what he made his so-called Moray valves out of. They were like radio valves, but were not using a heated coil like radio valves. They were all cold with no external power to feed them. They were a mixture of semiconducting materials and intricate one-way conducting materials. The Moray valve was therefore a solid-state device, unlike a radio valve that heated a plate to produce the energy. These valves are one reason why patents were continually refused, as he was told, there is no such thing as free energy. You must put energy in to get it out, as the patents were applied for. There were refusals due to the fact that the patent applied for infringed other patents. The patent applied for infringed other patents, even though Moray patiently wrote details of how this could not be. The patent office refused to allow any. In the beginning, Moray had to work out where the energy he was using came from. He eliminated the Earth itself, then realized that it was coming from space, but that it was not a static energy, but one that came in waves, like waves in the sea, more by day than by night, but still coming into the Earth all the time from what Moray called the giant reservoir of space. Moray began his interest when he was just 9 years old, when he was playing with toys. The total energy involved in cosmic radiation is very large. The mechanism of its generation involves a basic relationship with the total structure and action of the universe. Today it is believed that cosmic radiation consists primarily of protons and some heavier nuclei, coming continuously with slight variations in time. The radiations have a uniformly directional isotropy. The Earth is therefore surrounded in an atmosphere of radiation with cosmic rays coming in continually to the Earth from all directions, although there may be a slight deflection of the weaker rays by the Earth's magnetic field. There is every indication that our Sun is not the source of any appreciable amount of this radiation. The origin, therefore, is from the universe as a whole. The total energy of the cosmic radiation is more than the entire luminance output of all the stars and nebula of the universe combined. Unlimited power is being delivered to everyone's doorstep.
That's a lot of power.
Absolutely. The Moray radiant energy discovery using radiations from the cosmos as its power source gives the greatest amount of energy per pound of equipment of any system known to man. Electrical power from an electrical motor or an electric jet far exceeds any form of energy in an engine in the delivery of power. There is no dead center of lost motion in an electric motor, no loss or push in an electric jet. Also, the starting torque is much higher in the electrical powered engine than in the combustion engine. Quote, Team Emery Moray exact words. Harnessing cosmic energy is the most practical method yet discovered by man. Furthermore, it is possible to utilize this vast source of energy from the universe without a prime mover at any point on the Earth, on the ground, in the air, or the water, under the water, or even underground, if one considers that an electrical generator is not in the true sense a generator, as electricity is not made by the generator, but is merely an electrical pump. The Moray radiant energy device may then be referred to as a cosmic ray pump. That is a high-speed electron oscillator serving as a detector of cosmic radiation which causes a pumping action or surging with its circuitry. In the 1930s, Moray developed advanced semiconductors and transistors. Moray refused to sell his technology to corporate interests, fearing its misuse. Moray reported that he and his family had been threatened and shot at on several occasions, and his lab ransacked to stop his research, and public demonstrations occurred outside his home. Moray, as Nikola Tesla before him, was unsuccessful in introducing his device working on this principle. Some report that his secret was forgotten. As mentioned above, Moray tried for several patents to no avail. Radiant energy that is transported by waves. This includes energy transception in the form of waves through space or various media. Radiant energy is also energy transferred through electromagnetic waves. Solar energy is a type of radiant energy. Radiant energy is the sum total of all the energy that comes to the Earth from all the universe. The Earth also reflects back radiant energy into the universe. Our sun directs electrically charged particles towards us. Radiant energy may be calculated by integrating radiant power with respect to time. Radiant energy is usually expressed in joules. Nikola Tesla worked out of the conviction that, in his own words, the new power for driving of the world's machinery will be delivered from the energy that operates the universe, the cosmic energy whose central source for the Earth is the sun, and which is everywhere present in unlimited quantities. Moore had used the term radiant energy to describe that source of energy coming from the cosmos to Earth and radiating from the Earth back to where it came from. This is the energy the Moore device captures and could be described as those particles of energy pervading all space. Dr. Moore resented the stories often told about him that exaggerated the truth. He felt that the people needed to know the truth, whether they spoke for or against him. On occasion, he confronted people who were talking about him, telling them of his work when he was aware that they knew nothing about it. Now, this picture above, he lit all these light bulbs up and stuff he done with it. Picture above shows Moore demonstrating the potential of his device. The unit was running 50 times 100 light bulbs and 655 watt hot point iron. This proved that the device was not running off batteries, as his distractors said it did. He was like Tesla, a private man who did not easily get on with people. There are rumors that the Russian became very interested in his work and attempted to find out more about his radiant energy discoveries. It was of great concern to Moore that agents of Russia were attempting to obtain information about his discoveries. They were calling over to his place and attempting to befriend him. It is a known fact that the Russians became very interested in Tesla's so-called death ray, and the fact that Tesla had mentioned that it was possible to harness the energy of the universe to produce a scalar energy field and scalar weapons which would be so powerful and awesome that war would be abolished, as no nation would be able to launch an attack due to the scalar field, which would simply vaporize anything that came near it. The Russians was extremely interested in so-called scalar technology, or zero-point energy technology it's sometimes called. However, Moore, like Tesla, was frightened that in the wrong hands this would be a disaster. There is a rumor that to stop Russia getting this technology equipment was destroyed by Moore's assistant, or the equipment was destroyed because Moore refused to unconditionally hand over all aspects of the devices he had built. It was further stated that one of his sons dumped the entire contents of Moore Labs into a river because of continued threats and harassment, not only to himself but to his family as well. Moore was wounded by shotgun pellets in his lab by an attempt to frighten him into handing over the secrets of his work. It was certainly no picnic for Moore or his wife and children. In fact, Russia did have a scalar weapons around the early 60s. There is now the famous disappearance of the US nuclear submarine on patrol in 1965, the US nuclear submarine Fletcher. I expect you know about that, Paul. Moore had two favourite quotations from Tesla. Throughout space there is energy. If kinetic, and we know it is for certain, then it is a mere question of time when men will succeed in attaching their machinery to the very real work of nature. Second, from an old text, the nature of the world and of man. Enough energy is coming to the earth to light over 1.5 million 100 lamps for every human being on the earth today. In other words, limitless energy. Without the use of prime mover, no fuel of any kind need to be taken as a dead load, since this energy can be picked up directly by ocean liners, aeroplanes, or any other transportation. Heat like power can be made available for all use in all kinds of building and for all kinds of machinery. An example would be to pump water into the desert lands. A power source only be a fraction weight of any steam plant or any kind of engine in use today, and all of this at a fraction of the current cost. A wild dream? No, it's a proven reality, as hundreds of people now who have witnessed the Moray radio energy invention powered from the cosmos, so stated Thomas Emery in the original edition of his book, The Sea of Energy in Which the Earth Floats. Pictured above is one of these Moray's machines, lighting up all the bulbs. Nikola Tesla insisted the energy of the universe was waiting to be tapped. Tesla said, "We are like people in a boat, dying of thirst, because we do not know how to scoop up the water from the sides of the boat." Great scientists have mathematically proven its existence. Why has this great source of energy been ignored? Is the reason political or economic? No prizes for guessing this one. Someone famous once said many years ago that the Earth was a mental institution that the universe sent all its patients to. It is well documented that Moray developed a bipolar semiconductor as early as 1927, making a complete disclosure by Dr. Harvey Fletcher of Bell Laboratories. Below is Dr. Harvey's declaration 2 years before his death. And this is it. This just finishes this article off. This is a guy who knew and worked with him anyway. Harvey Fletcher, being of sound mind at the age of 94, on this 25th day of May 1979 in the city of Provo, Utah, do make the following declaration of my own free will, to wit: according to my memory, in the year 1928, while I was employed by Bell Telephone Labs in New York, I was invited to Utah by officials of the Mormon Church with the approval of my employer to observe a demonstration of a device invented by T. Henry Moray of Salt Lake City, Utah. The device was contained in a small wooden box about 18 by 24 by 24 inches long, which I personally inspected and determined that it was connected to no prime mover but only to an antenna on the ground. The electrical load on the device consisted of 12 clear 75-watt 110 light bulbs and 500-watt electric flat iron, also 110 volt. Then the antenna and ground were connected and certain adjustments made by the inventor internal to the box. The loads were electrically operated. I was permitted to inspect the interior of the box and certain of the schematic drawings pertaining to the circuits involved in the device. I was not permitted to inspect a plug-in unit, which was removed and held in the palm of the inventor's hand, which he stated was the most proprietary part of the apparatus. I did not know how the device functioned and do not know today, but I do know that it did function for several hours of time that I observed it. I could discern no batteries and could observe no other known methods of inducing electric power into the box or its loads. Signed, this 25th day of May 1979, Harvey Fletcher. And that's
what a big loss to mankind, eh?
Yeah, well, that's right. I mean, it says here, it dates from he was 9-year-old. He had successfully demonstrated that radiant energy would deliver as high as 50,000 watts of power. Mr. Moray was harassed, threatened, and even shot, even though eminent scientists examined his device during and after his operation, admitted that they could not understand the source of the power they had witnessed, still was never able to gain the support for his work. It is interesting to note that the greatest opponents of his work became the greatest competitors. Dr. Harvey Fletcher gave an unequivocal endorsement to the Irving Institute regarding the radiant energy device and what he had witnessed years before, where he had refused to do so for Dr. Moray. Over the 75 years T. Henry Moray's research, he left behind him a wealth of notes, not only pertaining to radiant energy, but a wide range of scientific research bordering all the way from the vulcanization of rubber the influence of mineral reactions in the presence of high energy by electronic effects. He left behind two sons, Richard R. Moray and John E. Moray. Today, a number of other researchers have entered the field. However, his sons have refused to endorse any of their work. And there we are. So I mean, I thought I would mention this chap because he's not he is well known to people who are, you know, into electronics and study of radiant energy and all forms of energy, but you don't hear too much about.
The general public don't seem to know him, do they?
No, well, I'll throw it open to you, Paul and Bock, if you've got any questions about it. That's about it for me for the moment. There's a hell of a lot to cover with Tesla. I mean, what a fantastic scientist. Oh, termed as a crackpot in the end, but I can't see. Without that man, we would not have what we have now. It'd be a completely different world. And it's a shame this guy wasn't allowed to, well, allowed. That's the word, isn't it? Allowed.
Yeah. Well, they had to demonise him, didn't they? They just had to demonise him so they could get away with their dastardly plans of putting it under wraps and keeping it away from mankind. Because they don't want mankind to get free energy, because they want to make money from it, from their own oil energy, etc., copper wires and what have you.
Absolutely. And, well, make money, it's the control, isn't it? That's the thing, Paul. It's about control. They would not be needed, would they? If everybody was...
No.
If we could generate our own energy, what on earth would we?
They need us to rely on them, so they've got control of us.
Absolutely. I think anything to add, Bob and Book? Any questions?
Yeah, I was going to say, Andy, very nice articles. I think it's becoming more and more realistic that, you know, we could literally pull energy out from the air, and this radiant energy, Andy, is this the same radiant energy that powers the solar voltaic cells? I wonder.
It's solar energy. Radiant energy, I think, is a term that's used for everything. You know, radiant. I mean, the solar cells which rely on the UV light and that from our own sun. Yeah, because you know, and I know, Bob, you've messed around with solar cells and solar panels. Once the darkness comes, there's 0 voltage.
Right.
You've seen that for yourself, haven't you?
Right. Yes.
Yeah. Well, with radiant energy, no, you still collect energy, and that proves that it's coming from elsewhere. And I've done that myself. I built a little. I mean, if people are really that interested, you know, you can go on to on YouTube and just Google free energy collector or free radiant energy collector, and you'll see 1 or 2 circuits with a. I mean, I made one out of a capacitor and 3 diodes, and I connected up to a bit of long wire, copper wire, which I've got going over the roof here, and the other end goes to the ground. And yeah, I can measure up to. I have actually measured up to about 5 or 6 volts, and but normally most days and evenings it's around about a volt to 2 volts, or just below a volt, and it's microamps in current. But all said and done, if you put a meter in line and you watch the voltage, you can see this burst of energy at night time coming through. Now the sun's not there, so it can't be coming from the sun. So it's cosmic rays. It's all the other energy that comes from the universe. So radiant energy. I think you probably could include the sun in the daytime, because it's coming from it's coming from outer space. It's coming from the vacuum. Of space, but as a term, radiant energy, I think is the total everything, cosmic rays from other galaxies, other solar systems, other galaxies, and maybe if you're a multi-universe guy, other universes. Who knows?
Right.
You know, that's
Well, it's either the yeah. I was going to say, well, it's either the source has either the source is behind the the energy of the sun, or the sun is behind the energy of these radiant energies. But it seems to be that there's something behind the sun, right?
oh, absolutely. I mean, the sun comes from the radiant energy. Everything comes from the
Right,
radiant.
right. That's what I was trying to get at, I think. Yeah, yeah.
Nebulas and these cosmic clouds, which scientists say it's where stars get born with the accumulation. It's all radiant. It all comes from other galaxies, other parts of the solar, other parts of the universe, and it's a collection of radiant energy. So everything comes from radiant energy. If you want to call it the 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 source of life, I think we are radiant energy in that respect. We come from radiant energy. Everything comes from radiant,
I
So
mean,
that's how I look on it.
even to build these devices, you still need copper wire. Now, it just shows you the greed and the control freakery of Morgan, doesn't it? Because he could have still sold his copper wire, couldn't he?
Well, yes. Well, this is the Edison question as well, isn't it? The DC man. I mean, he hated the idea of AC because he knew that it would pretty much render the DC generations for power in cities and things into the dust cart, which it did do.
Yeah.
I thought that was an excellent move on Westhousing of doing it at a grand exhibition, lighting up with AC, and that totally knocked JP Morgan on the head, didn't he? Didn't it? Oh.
It did. Well, I think it was Westonhausen and Edison put in for the contract for lighting that fun fair, wasn't it? I can't remember the name of the city. Yeah. That's right. And Westonhausen said he would do it for about half the amount of money that Edison quoted him to do it from DC. So Westonhausen got the contract under Tesla, and the rest is history. I mean,
then because of that, he then got the contract for doing the electric on the dam, the big dam in America.
That's right, the hydroelectric. Yeah, the hydroelectric setup. Yeah. Niagara Falls, where he powered Buffalo and New York, wasn't it?
Yeah. So through Tesla, we got hydroelectricity.
Yes. Yeah. Of course. That's just one of many other. Many other things. I was talking to Bock earlier on that he actually inverted that, that turbine, the disc motor, which really was 60% more efficient than the piston engine. But they went with the piston engine. In actual fact, that disc, I call it a rotary engine. I think it's a forerunner to what Wankel picked up in the 50s. And made the rotary block out of. I really do, Paul. I really think that's where he got the idea from.
Did you think that Moray might have actually known about piezo crystals, piezoelectric crystals?
Yeah, of course.
Do you think it might have been a piezoelectrically crystal he had in his hand? If he could hold it in his hand and keep the device out of view from people in his hand, it's got to be some kind of small crystal that's going to line up the waves.
Anything's possible. I mean, he made his own. He made his own valves out of his own stuff, which actually operated without heaters. Now, if you know how a valve works, you need to heat up the grid between the anode and the cathode to get the electrons to flow across the anode to anode and cathode.
So would they use electricity to start with to heat it up then?
No. That's the conventional way of doing a vacuum tube amplification. But what he done was he didn't use heating element. He just used I think I read it was some type of crystal or mix of stuff where it was a cold energy, i.e. they didn't need. So in actual fact, he actually, thinking about it, he developed the transistor. There was a transistor in what he actually developed, basically, solid
well,
state.
well,
I think,
Marconi's took that and run with it, didn't they?
yeah. Well, I think by the reading of it, I mean, I don't know the
Is that where the definition of solid state comes from, Andy?
Yes, yeah, the
In
transistor.
electronics?
Yes, solid state. Yeah.
Ah, right. Okay.
Solid state is by transistors, which is basically two states to a P material and N material, which is silicon doped with arsenic.
Uh-huh.
That's how they make
Yeah.
and that's how they make computer chips. Everything inside your computer is solid state, which is
Solid.
which is a process of doping silicon with certain amounts of arsenic.
Yeah.
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 A modern age alchemism, if you like, Bock. Yeah.
Oh, I remember growing up, it was always just this definition we applied to stereos and hi-fi. FM stereo was like the big thing at the time, you know,
Solid state.
and they were advertised as solid state, you know.
Yeah.
Well, don't forget, I mean, it was a great invention to come along because all of a sudden, instead of having
Yeah.
like big transformers and valves and big heavy things and high voltage, HD voltage, you could get this piece of silicon that had three legs on that would do the same as a glass vacuum electrode sealed inside a vacuum of glass, and and the transformers to run. Also, there's a little bit of plastic, basically, if you looked at it, but of silicon, and it done the same
Wow.
job. So you all of a sudden you could buy a radio that you could put in your pocket.
Yeah. That was the age of the start of the miniaturization, wasn't it?
Yeah, well, transistorization, I call it. But you know, that's basically. I think he had a hand. Maybe they stole his papers again. I don't know. Maybe he was a forerunner. He's saying that he's got from what that guy writing that article saying the way he made that valve, without a heater, and he was using certain things. He maybe in 1927 actually devised the first transistor.
Wouldn't surprise me at all. Sorry, Bob.
30 years before its time. 25, 30 years before its time. So, it's amazing actually, these articles. You come across them. I've never read them before in my life, so they're great finds. I mean, some people might say, oh well, conspiracy theories and all this stuff. No, the guy lived. He's done these experiments. He made these things just like How can anybody dispute Tesla, for crying out loud, as a madman? Because the world wouldn't be like it is without him. I find that most bizarre.
It just shows you how much further they are ahead in the technology in their little laboratories. I mean, Tesla was ahead back then, and that they took it and run with it, but they gradually fed it out to the people so they could make money yet again on it and have control yet again. Yeah,
well, it's leaking out there, and because of the internet, and because things are not quite working out the way they're planned with the internet. That's what I feel. I feel that if they made a boo-boo, then it was the internet was the best boo-boo they ever made.
Boo-boo, I think, of many centuries.
Well, and if you go on YouTube and check Radiant Energy Collector or Free Energy Collector, you'll see guys with components and wires and test stuff, and it's great to see because people are experimenting and they're picking up on Tesla and Moray and other scientists' work which got trampled on 100 years ago and resuming the work today, and some of them are having some good results. Even myself, to dare even just to put a few components together and connect a bit of wire and put a multimeter on, I go, hey, it's there. It might be minuscule compared. You can't run you can't cook a meal with an electric cooker off it at the moment, but it is there. And if people just even do that, and I'm no great shapes electronic circuit builder, I'm pretty basic.
I can well
do that. Then anybody can,
I can well imagine they have already got that technology in their little black laboratories.
Well, if the people force it out, Paul, if the people get and say, well, I don't care whatever, I'm going to put it up there. I'm not going to patent it. I'm not going to operate commerce. I'm not going to sell it. It's just for free. What?
Yeah,
Well, you know,
it'd be a case of the 100 monkey syndrome, wouldn't it? And then it just gradually grow that everybody knows about it because it's such a fantastic thing.
hmm. I
Before
think it's freedom.
these big rich moguls get their hand on it and shove the patents in their safe so nobody can get at them.
Well, the Nikola Tesla, I pulled up the radiant energy patent. Anybody can get it. It's a PDF file. He patented it, and then there it is. It's on the internet, and you can go into the patent office and pull up any one you want. Yeah, and he patented it, and there it is. So people can look at the circuit. They can work out what they've got to do.
Yeah, but it does need somebody with a certain amount of electrical knowledge already, because I wouldn't be able to do that because I wouldn't have a clue with electric. I mean, the first time I ever found out about electric, I was about 5 or 6, and I went round my mate's house. He was a year older than me, and he said there was this lamp stand standing on the table, and the bulb was out of it. And he said, "Do you know what electric is, Paul?" I said, "No, I don't." He said, "Put your finger in there." And I put my finger in there, and whammo, I was crashing up against the kitchen door, and as I was falling down to the floor, he said, "That's electric." So,
Well,
220.
yeah, well, with radiant energy, you won't get any of that, provided you're not silly. There's a guy on YouTube, and he's lighting up bulbs and fluorescent tubes while he's grabbing the terminals underwater. You
wow.
work that one out and not getting a shock. Anyway, I'm rabbiting on. I'm going to put it over to Bock. I think you've got some more interesting
Very good
with us.
very good articles and the extra information that you put along with it. Very.
I did try. Hopefully, some of it made sense. That's all I can say. So, yeah,
Well,
if you want to put your screen share on, Bock, I'll
yeah, it certainly enlightened me, Andy.
No, you're all right. Okay, Bock.
And I was wondering how we could, not us necessarily, but how the rodent coil and these other technologies could be implemented, along with all the other advancements we have made already with, I know, solar panels. We have more efficient solar panels now. We have, and the electrical brushless motors we were talking about earlier, Andy.
Yeah, okay, but can you just run over the very beginning again? Because we lost the first bit because I don't know, for some reason you was on mute. But
Yeah, I lost it as well.
do you want to go over the
Oh yeah, sure. Yeah, I was saying I just wanted to add a bit to what you were saying earlier, Andy, and I was saying how it would be possible to implement the other technologies we have and other alternative electronics and like the brushless motors now, and the rodent coil, how it could be used in so many different areas. And by the sounds of it, it seems to be a very similar type of energy collector as the one that Tesla was describing, Andy.
Well, I think the rodent coil, the vortex energy, that that I was reading earlier on. I wished I'd got the article, but I think even guys around Tesla's time, there was one or two other scientists. I'll see if I can find it sometime and get it over to you, Brock, and maybe put it up on Axiom as well. They were talking about vortex energy, so it's not a new thing. But I must admit, Mark Rodin's um, attempt at of making a coil, or the number system. I mean, it's other people that's made the coils and that out of it. Is that it's very similar to a coil when you look at it, and our electrical magnetic. That's right. Yeah. How the actual electromagnetic pattern of the coil of the field around the coil is very much basically very much like how the energy operates within this universe and etc. From what bits and pieces I have seen for it, but that's the one there. Yeah, you want to carry on, Bob?
Yeah. My hands up for you putting that on Axiom stuff.
Eh?
My hand is up for you putting that on the Axiom community site.
Okay. Yeah. Sure. Sure. Well, this is yeah. Do you want to explain what you got there? That's the coil in it, the rodent coil, Bob.
Yeah, I just thought I'd share the picture of it, and right below it, it says the rodent torus coil tested at Hewlett-Packard was determined to be creating 62.5% greater magnetic outputs than the present-day standard wound electrical coils.
So is he winding it up like a torus to get a torus field?
Yeah, exactly, and it appears to actually mimic the true pattern of the toric field.
Wow.
Yeah.
It's like if you've seen Nazim Harameyn's explanation of the unified field, Paul. Yeah.
I have actually seen it, but I would like a refresh. So if you can come across the link, I would like that as well, mate.
It's very it operates the same way, and it's done by a number system that Bob perhaps would like to explain a little bit about, because I know you're well into the rodent math, Bob.
Right, right. Which number system in particular, Andy, or just in general? Oh, am I muted?
I heard you, but I couldn't make out what you were saying.
Okay.
Okay, can you hear me now, Andy?
Yep.
Yeah, I was just saying, was there a number sequence in particular, or just in general?
It was just a sort of like explanation of the doubling circuit, how it works basically. I know it's based around.
Oh, right. Yeah. Well, it's the only mathematical way that we have that. Well, not the only, but the most realistic way of describing infinity in a mathematical equation is by using this doubling sequence. And if you just simply start with 1, you double to 2, 2 doubles to 4, 4 doubles to 8, 8 doubles to 16, and then you take the 16 and you break it into its base 9 number, which you add the 1 and the 6 gives you the 7. You double the 7, and you get 14, and the base 9 number of 14 is 5. And when you double 5, you get a base 9 number of 1, and therefore it repeats the pattern over and over and over. And this pattern in particular seems to just be the perfect harmony of mathematics, where we find the Tesla 369 field also shows up in this math, the doubling sequence, and we also have the continuous 1 to 9, 1 to 9, 1 to 9 numeric system. And it's just just perfectly balanced. It's the only way to describe it.
Yeah, I think I would call this the golden mean of the mathematical sequencing.
Right, right. Well, it's a part of it, Paul. The golden mean is a part of it.
Well, that's the
Fibonacci sequence, like the spiral pattern. I believe pi.
Yeah.
These guys say that the pi is also found. Because they deal with the base 9 number system, it simplifies a lot of the complicated math. You know, I'm not an expert in this. I'm just really fascinated, and I've just taken a self-interest in this. But from what I've read and heard from other people, they just say that basically it's simplified without going into really heavy-duty, algebraic equations and stuff. It'll simplify it in a way where, and then you can make you could work out how it balances, right? And that's the whole key, is to find the balance.
Yeah, I think you would call this like the breakaway. Like the golden mean is for nature. This is the mathematical sequencing for the mechanical type side of things.
Yeah, yeah, that's right, Paul. Yeah, it's kind of like energy and electronics in a way, where they're two sides of the same coin. The dualism, the negative and the positive, and
wow.
I know I followed a bit of what Maurice Cotterell talks about in energy, and they talk about it in the same way, where it really, the negative and the positive, it's just the two sides of the same coin. And the same thing is happening in the Rodin math and in the etheric field, where the 9 is the middle, and the 6 and 3 are just jumping polarities, and they're being like the negative and the positive.
It's just like that wave that STAV was shown us to begin with. It's the same either side of the baseline.
Exactly.
One is the mathematical sequencing of
the sine wave
side, and the other is the golden mean sequencing of nature.
Yeah, exactly, Paul. The chart he was showing was the sine wave, and he was saying the 0 point is in the middle of the sine wave. Yeah, that's exactly the same thing.
Yeah. Wow. That's beautiful information with your article and stuff. How that has come so together, really.
Yeah, I think it's everything's in wave. It's the particle and the wave. It's like when you get these articles with quantum physics now, the particle and the wave. It can be either or both. With the double slot experiment, if people go and look at that, that pretty much explains it. The sin wave is the pattern. That's the pattern of the electromagnetic wave, that everything that is, everything that's atomically spinning, even the monatomic atom, which is the most simplest atom, I think, from right their book. I'm a bit.
Well, you can see there's a sine wave in the coil there, right?
Yep. Yeah, you can see it. Yeah.
And so that's basically what's going on. It's a continuous sine wave within itself.
Yeah.
I guess that's a small kind of a small container for ether induction.
Well, there is a theory, the Planck's theory, or whatever it is, where the 0 point. If we take, Paul, what we were saying about the 0 point in the middle of the sin wave. Yeah. If you can tap into the 0 point of the sin wave, they reckon in space, 1 square centimeter of space, energy has the same amount of energy on everything in the universe you can see.
Right.
Wow. I mean, even that looks like a plan view of the torus force field. So if you imagine in the centre there, the other side is what you see this side, and that's just like the torus field. Like looking down on the top of the plan view.
Yeah.
Yeah.
And that is the centre point, which will be the centre point. That's that centre line that we was discussing earlier.
Yeah, and the beauty of that, Paul, is those coils of wire that you saw earlier in boxes, what they call Rodin coils, which are
Yeah.
wound to this mathematical formula of Rodin math of the doubling circuit that Bock was just putting to you there. That
Mhm.
that electromagnetic field is exactly like the torus field. It is the same.
Yeah.
That's what it generates.
Yeah.
So, um,
That's great information.
yeah, so that's what you're looking at. I mean, um, it's the most.
Yeah.
I mean, a lot of people don't realise that this radiant energy
Yeah.
that I was referring to earlier. It's all the same thing. The torus field
Yeah.
is, this.
Just thinking here, staff.
Yeah,
Yeah.
yeah.
The could you imagine that being like the black hole?
Well, I think with Nazim Harameyn's theory, as far as I understand it, is you have black hole and a white hole.
Yeah, yeah, I think I remember that. That's what's maybe, but not nudge my memory.
Yeah, what gets pulled into the black hole at the center of every galaxy, which they say we have at the center of the Milky Way now, a black
Yeah,
hole, it gets pulled into there over the
horizon.
yeah, that's right, the event horizon, spaghettified or whatever, as the
I
theory.
love that word. Can
in,
you spell it? Sorry.
into the black hole, but it gets pushed out the other side of the. I guess I don't know. Perhaps I'm not looking at it right. The white hole, and it gets pushed around again. It's like if you look at those quasars. Have you seen the quasars? It's just a
Yeah,
spewing piece coming out the top and the bottom equal, and it goes round and round, and that's your torus field, and that's what a galaxy is. Just one massive
yeah.
grow a torus field with all the planetary solar systems within
Just
it, going
big,
round and pulled in, pushed out again, and it's
yeah,
an infinite motion of flux, if you like. It's a constant flux, and it's infinite. It's ever expand, and with along with the galaxies being new ones being born, it's a constant, infinite expansion of the universe, and who knows? Other universes within the universes within the who knows?
yeah. I'm really pleased that somebody had given me the nickname of Black Hole.
But anyway, that's as far as I mean. I might have got quoted that wrong from Mr. Haramein.
No, I remember recall that because I think that's what's made me think of it. You know what I was saying, like
Yeah, but I mean, this radiant energy, it's all the energy. It's everything. It's the solar rays from our sun, solar rays or whatever. If they're powerful enough from other suns in other solar systems in other galaxies, exploding supernovas, if you want to put it like that, quasars, all sorts of things, and everything
yeah, all the spaghettification of every little wave you can think of being redirected.
yeah. Yeah, it's a lovely theory and thought,
Beautiful. I think that's beautiful.
and that's but radiant energy. Wow, if we can,
Yes, we've been deprived. Mankind has been deprived by the rich moguls yet again.
I actually think that putting this out there in case other people do look at this and that, the rodent core has got a very very important part to play in this at this
Mm.
junction now. I think that is some form that could be used as some form of radiant energy collector. I really do. I really do think that could be put into the equation somewhere, Brock, don't you?
Yeah, that's what I was thinking as well, Andy. Because it can be implemented with so many different things. Because the design is so efficient, it can make the windings of all the motors, all the engines can be far more efficient, and less copper is used. Um, and I really like what you were talking about, Andy, with experimenting with different ways of trying different antennas to pick up the radiant, the cosmic energy, and then perhaps I think you mentioned it that after picking it up through what do you call it, a dipole type antenna, and then run it through a rodent coil to see if it could be enhanced in some way. Eh?
Yeah, well, I have actually, I did build a kind of Tesla coil the other night, um, but I did mess with the rodent in conjunction with it, and I got some pretty bizarre results. Let's just put it that way, Bob. I
Right,
wouldn't
right.
say what they were because I didn't actually. There was results in a fashion that I couldn't quite understand. I'll talk to you about that some other time. I don't know why it affected things the way it did, but it did. And I thought, well, surely if that happens, this will happen. And guess what? It didn't. The secondary action I thought would happen didn't happen, and it defies all logic in conventional electronics and everything. But I'll tell you more about that some other time. So that
Can you
was quite
call,
interesting.
can you call me in on that call, please, Stav?
Yeah, sure. I'm sure other people have come across it, but um, it's it was quite interesting to say the least. And I thought, well, if that's the case, then our old rodent coil is certainly doing more than I thought it would do. But 60% would seem hmm, actually
But
enough value for it, Doc.
Mhm.
Actually, I would say it was more
There
than.
was there was that PDF you shared with me, Andy, where it had so many different applications. Like communications, I believe, was one of them.
Yes.
And then that got me thinking about the different types of antennas and the different geometric designs of antennas, and because I know very little about electronics and stuff, so this I look at it from more of a visual perspective, you might say, but I'm trying to connect dots that way.
Yes.
Yeah.
I'm,
Well, you could.
I'm going way out on a limb here, guys, but that plan for you also, does it not look like a flying saucer?
Yeah. Yeah, well, there's the Starship one, which was the one they showed before, just now before that, which
Yeah.
is basically, don't know if you still got it, Buck, have you? Yeah? They call this a Starship coil, Paul.
Wow!
Here it is, there,
Yeah,
Starship.
yeah, crikey. Yeah, I think this rodent coil's got a lot to do with the progress of mankind. It's been withheld from us here.
Well, Mark Ryden, who, done the maths, and what was the name of the other? Well, he's just put it out there, and everybody, it's an open source to do what you want with the coils to do experiment. It's an open source, a world open source project for everybody to get involved that are interested and experimenting, Paul. That's the lovely thing about Mark Roden when he put it out there.
Yeah, yeah, I think the push needs to be pushed over a bit stronger, to be quite honest.
Yeah. Well, he's not going to. I don't think he's. I'm not sure if he's patented. I don't think he has he? But
I'm not sure about the patent end, but um, I know the people who were involved in it. It was Mark Roden and a friend of his, Jamie. Randy Powell is another person who's involved in the vortex mathematics. There's another gentleman, Daniel Nunes.
yeah.
He's done some work with the ABBA coil, which is related to the rodent coil, and there's a few other people. I haven't actually been keeping up with the whole thing, but yeah, like you said earlier, I was more involved in the mathematics end of it, but the whole it's all fascinating to me because it's such a wide area of implications. that that this has. I mean, the mathematics, the technology, the
Yeah, this is blowing my mind, guys. This is so, it's out there. Well, sorry, he's got to get it well out there.
I think the beauty of it, Paul, is that if you know a few little tiny basics about electricity and how the conventional way of harnessing it, and you know about electronics, about components and things like that, and what they can do. You need to leave it basic as basic, yeah. And what you can do is then you can look at this. If you can look at it, not a too. If you go too academical with this, you'll lose it. I think you won't find.
Yeah, because basically simplicities don't involve blinking academics.
Exactly. So you've got to be well outside the box. Well, you've got to be outside the box to bring this.
No, I think surely this is the realms of any capable mentally capable person. Surely, I mean, if I can understand this, and I'm not educated as such, I think the majority of people would understand this, and with the sequencing and that. Have you actually got a chart box with the sequencing on it? The number sequencing?
yeah, it's you probably can't see it from there, but the numbers are on here.
Yeah, I meant just a lot like in step as the numbers go up.
Well, the interesting thing is if you look at how the math is, if you go on YouTube and you look up Mark Roden and the other guy, what's his name, his mate, Bok?
Randy Powell.
Yeah, if you look at for Randy Powell and Roden coil, he'll show you the math and drawn on a blackboard or on a paper, you know, drawn out as he's doing the video, and you'll notice the shape of it is quite uncanny towards the old Masonic sign.
I've got to splice some time here, guys, to get into this. I've got to find, I've got to find the time because, this is so enthralling to me. It's because there's so many things that have come together during the course of my life just on this.
Yeah, well, everything's connected, Paul.
Yeah.
And the other motor you mentioned, sorry, Paul. The other motor you mentioned earlier, Andy, with it was a triangle shape.
Oh yes, that was the rotary engine.
Rotary engine, right. And you said it just mysteriously just got phased out of production.
Yes, that was another big kind of shelf it type operation, I believe.
It makes one wonder is it's possible that the reason they didn't want to promote that because they didn't want people to catch on to the geometry.
No, they didn't because
they just wanted to hand down this conventional method of wrapping their motors. Absolutely. And they didn't want people to think, oh my God, look what happens if I do this or that,
Well, you've nailed it there, Bob. You've nailed it there. Sorry, go ahead, Stav.
Yeah, well, in the centre, if you go and look at the block of the rotary engine, anybody can go and check this out again on YouTube. You'll notice that it's a triangular block inside, right? And it's a pyramid-shaped block, right? Which fires on three sides, and it pushes the angle of the triangle of the block round. And that's the rotary part. You don't need conrods, you don't need pistons, you don't need any of that rubbish. And you know what? For the size of the engine, physically, it's double the brake horsepower as a conventional piston engine.
And there's no actual wearing out parts.
No, it's a mystery to me. If you want to listen to a great motorcycle that was banned, a great motorcycle that was banned, right? And there actually was racing it in the UK, and it was beating all the Japanese bikes in the 70s, right? And it was called the Rotary Norton, a motorcycle company. Now they brought this thing out, and you had a couple of guys like Ron Aslam and somebody else was racing this thing, and they were wiping the floor with the Yamahas, the Hondas, the Suzukis, you know, conventional bikes, and
Wow.
it was a smaller bike, physically smaller. The engine was smaller. So what they done was they brought it. It got to do one what they call Grand Prix, which is the top-notch motorcycle racing. It's a bit like Formula One for bikes, you know, where all the modern cars and Mercedes and
Yeah.
you
So
know.
yeah. So why if something is that good, all of a sudden taken out?
Well,
And
they
I think Box nailed it there. That they just don't want people to cotton on.
no. Well, that's what happened to the rotary Norton. They said you've got to knock it down. The actual triangular block in the engine. It's just a triangle block that spins straight on the crank. All you need is gearing, and that is it. There is no conrods, pistons, all the rest of that, valves. You might as well just forget about all that rubbish. And when I looked at that, and I scratched my head in the 80s and 70s and 80s when this thing, and the Japanese said we're gonna we're gonna bugger off, and we're not gonna entertain motorcycle racing unless you ban it. So they banned it because Japan was singled out for the motorcycle industry. It still is today, and you can't go against Honda because they are the kingpin of it all. And if you do anything technologically against the Honda, it will be banned because it's the corporate cabal again. We come up like you say.
Yeah.
But,
It's,
it was one thing I thought, wow, why the hell ain't cars and bikes got? Why are they bothering still with pistons? Nice motorcycle in the picture, Paul, but I'm afraid the rotary engine, for its size and its brake horsepower, you don't need all that mass in the middle, man. You know what I mean? So, well, you know, and you know what? I think that came from Nikola Tesla's disc motor, his disc
Wow.
turbine. I think it came from
yeah.
that. Could be
It
wrong.
seems to be gelling together, does it not, guys?
Just a bit. Just a bit. I just never could understand why. And that was do you know what? That motorcycle, I'll just finish it on the Norton rotary motorcycle because we've gone off. Well, it's energy.
No. It's to the point because it all pulls together.
It used to generate so much heat out the back of its exhaust. The other guys, when they used to catch up with it on the bends, were scared, or when they got overtook by this rotary engine, the heat that came out the exhaust, right? The other guys had to hang back a bit because when it came past them, it was melting the visor on their helmets.
Wow, I didn't know that one stuff.
Wow.
There. So that gives you some idea of the heat that the rotary engine produces and energy. Now, I mean, it's a combustion engine, but it again, it had that. The secret was the triangular block in the middle. There you go. So anyway, just putting it out there. It's another theory, and yeah, it's energy, I guess. But yeah,
It's very interesting, that's for sure.
yeah, definitely. So anyway, anything else to add at all, Bob? I'm sort of interrupting you.
Yeah, I'll quickly touch on. I think we've talked about the. Yeah, I'll quickly touch upon the brushless motors, Andy. And
Oh yeah.
I was telling you earlier, I noticed that airplane companies were using brushless motors now. They were brushless motors, and they said they had magnets and a special winding sequences that they're using now. And so brushless motors have you know, they're good enough to be using them in planes.
Yeah, I wonder what that special winding
Yeah,
sequence.
special winding.
Yeah. I'm glad you guys caught that because I was gonna say I just saw it on the internet and I don't want to, you know, start pointing fingers, but somebody might have been taking advantage of the vortex geometry.
Yeah, definitely. I would. Well, we can't prove anything, but it just fits in, doesn't it, so to speak? But yeah, I think the short path what do we call it, shuttle services for airplanes, just local stuff. I think will be electric motors. And we, there was an interesting article not too long ago about the so many billion apparently the British government, Cameron and all the rest of them, have put aside into a project which starts, I think, next year, about the electric superhighway project in the UK. So,
Mm.
so this is cars. This is cars. Electric superhighway. This is electric cars, guys, and it's just round the corner. Things are going to change real fast.
yeah, and the cars that can drive themselves.
Absolutely, autonomous will be the name of the game.
Yeah, so you can do away with any kind of delivery drivers,
Yeah,
basically. Uh, well, we're moving into the transhumanism, so
yeah,
we've got to move in all kinds of different sectors in different ways to get that achieved.
yeah, definitely. Yeah, well, let's see. What I'm sorry, Bob. Do continue.
Yeah,
No, no, no
sorry.
worries, no worries. This was just my final article today. Uh, there's a Japanese man who's apparently invented a machine that converts plastic back into oil,
Huh,
and then it can be used as gasoline or other petroleum products all over again.
wow.
Yeah, I
I
did
thought
actually
that might
see
be
that.
certainly.
Good on him. Good on him.
Yeah, I think everything has its place. I'm not 100% sure that the the standard combustible engine can be eradicated once and for all, or I'm not sold on uh, many other things. But I think that if we incorporate them all, that's the way of the future. Is the more stuff we're using, the more forms of different energy, the more solar, more wind. Everything seems to be improving, and with the improved motors and with these ether energies and the rodent coil energies, and I think there's a lot of potential. That's for sure.
Yeah, definitely. Is that
And
a
and
video?
with guys like this who can solve some of the plastic problem, like if we can stop uh, the
Oh,
production of meaningless plastic. I mean, we plastic has its purpose. We like I said, we probably might not eradicate plastic entirely. It has its purposes somewhere, but it
yeah.
shouldn't end up in our oceans. And maybe this is a one step towards that here.
That's cool. Are you going to play the video, or did you just use it as a?
I mean, there's not much to it. You can see it's just a box, and he's literally just putting out all the plastic wrappers, and he said you can just throw it in as is,
Oh, cool.
and the machine will convert the plastic into oil. Yeah. In fact, there was another one here. I'll leave the links. We'll leave the links on the end of this video description. There was another one here too. This is a young lad here. He managed to make a similar one where he made a homemade oil refinery, turning plastics into oil. So yeah, I'll leave the link to that one as well. So yeah, I just wanted to show you guys that these possibilities are out there. We've got a lot of solutions out there, and hopefully the people are able to use them.
And I think it's gonna have to come from the people. A lot of this stuff, apart from the uh, electric superhighways I just mentioned, which will probably private ownership of vehicles will go by the by, because if it's autonomous electric vehicles, then people privately owning vehicles will cease to be. That's looking on it in a negative. But on the positive side of all these things, like that one you just showed, the one with refinery from plastic, and taking plastic and putting it back into fuel, which you can put in your car, the radiant energy collectors, the vortex energy, all of these things
Yeah.
are going to have to come from the people. It's going to have to come from the people because, you know, it's not going to come from the cabals and corporations and
Yeah,
whatever, because you know they
yeah,
don't need to have it.
yeah. They're holding out tomorrow, so it's still in yesterday.
Yeah, because our current recycling of plastics, it's a very poor standard. We're only getting something like 30 or 40% of recyclable material back.
Yeah, it'd be nice to see less washed up on the beaches.
Yeah, oh,
Yeah,
absolutely.
and that for sure.
But less in whales and sharks' stomachs and tangled around turtles' necks and yeah, all that
Yeah,
stuff. Yeah, uh, again, you know, just like the Wankel engine or the rotary engine, there's been some fantastic inventions out there, and they've been deliberately suppressed and left by the wayside. And you know, I think regardless of the reasons why, we know the reasons why pretty much. I think people just need to get on with their own stuff and for God's sake, get off that television watching EastEnders. Why waste your life with that rubbish? I mean, let's be honest.
Mm.
Anyway, that's my thoughts on it. I watched an Alan Watt video today, so I'm probably in one of those moods. So I better get off that subject.
Nice.
Okay, right. Okay, dokie. Well, anything else from you, Bob? Are you done?
Yeah, that's it for me. Thanks.
Okay, well, that's great. Good articles, all about energy. I hope anything to add, Paul, before we close the show?
well, I'm just glad that I did manage to splice the time to come on with you guys tonight. But yeah, I'm absolutely, you know, want people to know that they've got our tomorrows imprisoned in yesterday.
Yeah, that's it.
Ah.
Very good, Paul. With that, I've been told, yeah, a little bit of promotion. We Axiom Curb does have a website. There's all sorts of interesting stuff on there. Do become a member, sign up, and also we're going to try and get some live chat sorted out for that. So it would be nice to use that as a medium too. Lots and lots of articles on there. Do go and have a look and have a read and see what you're thinking if you like. Join up. And
Yep.
of course,
Leave any comments and suggestions. That would be great.
yeah, absolutely, there or here on the bottom of this video. And also, if you want to get in touch and want to join our Sunday evening chats about all sorts of topics and things, just give us a tinkle. Anybody's welcome. So, and everybody's welcome. Whatever. So, with that, thanks, guys. Very interesting evening. Thanks for the articles, Bob, and thanks for your input, Paul.
Oh, thanks for letting me know, guys.
No worries, Paul. Do it again sometime. Cheers, Paul. Cheers, Bob.
Yeah. Likewise. Thanks, guys.
Take care, Bob. Take care, stuff.
Yeah. Keep your tongue out.
Yow.